So actually F is equals to 1 by 4 pi epsilon naught Q1 Q2 by R square. So this is the formula which we use to find out magnitude of the force between two charged particles. It may be a repulsive force or else attractive force. But in advanced level, you'll get problems like they'll give you a uniformly charged rod or ring, etc. For example, if you take a uniformly charged rod, let me consider a rod. This is the uniformly charged rod, right? It is linear. Okay. Here, this is the uniformly charged rod, and now this rod is charged uniform. That means the charge distributed uniformly on this rod. The charge distributed uniformly on this rod. So we can call, I mean, its linear density is lambda. Lambda in the sense nothing but total charge on the rod per total length. This is called charge density. Total charge per total length, right? So and I'll take a small Q charge at this point, and this is charge on this rod is capital Q, and I have taken a small charge Q here. Now the distance between these two is R, right? Now the thing is, what's the repulsive force between these two objects, right? This is the question will be. And now to find out that, first of all, I'll take a very small element. A small element I'll take, which is dx. Width of, I mean, a very small length of dx element I'll take. On this dx length, the charge is small dq. A very small charge will be present. Since the rod is uniformly charged, distributed with the charge, then I can write lambda as dq by dx also, because the density is same, right, throughout the rod, right? This dx is at the length of x distance, right? Let's consider from here to here distance is x. Okay, here the distance is x, and now first I'll find out the force because between dq and capital Q, then I will integrate, then I'll get the total force. Got it? So df is the force because I have taken a very small charge now. Because of this small charge, I have very small amount of force. Okay, yeah, df is equals to nothing but the force between dq and q, right? 1 by 4 pi epsilon naught q and dq by x square. Clear? So now if you observe, I can write this as capital Q by L. From this I can take the value of dq, that is equals to q by L into dx, right? I'll substitute this value in this equation, right? df is equals to now 1 by 4 pi epsilon naught q, and what is dq? Capital Q by L into dx by x. This is the equation for the a small amount of force between dq and q. If I integrate this, then I'll get a total force, isn't it? Right? Let's integrate. Integral df is equals to 1 by 4 pi epsilon naught and small q capital Q by L integral of 1 by x square dx. Hope you understood, right? Yes, I have taken all the constant values outside, and then I'm integrating this 1 by x square. Right here, I told you that, right? What I told you, the length of the rod is L, right? The length of the rod is L. So the rod starts at the distance of R and ends at the distance of R plus R, right? So the minimum, I mean, R plus, it starts at R and ends at R plus L. If you observe, these are limits, right? A minimum distance is R and the maximum distance is R plus L. Clear? Now let's integrate it. Okay. If you integrate this, you will get F. You will get F. That F is equals to 1 by 4 pi epsilon naught small q capital Q by L into, here if you integrate 1 by x square, it gives you minus 1 by x, right? Yeah, actually you have formula also for this. Like for example, if you integrate x to the power of n, integrate x to the power of n dx, then you will get x to the power of n plus 1 by n plus 1, right? Here if you take x square to uh, upside, then you will get x to the power of minus 2 plus 1 by minus 2 plus 1. Then this value will be equal to x to the power minus 1 by minus 1. So simply I can write minus 1 by x, isn't it? Right? The lower limit is r and upper limit is r plus l. So the force F is equals to 1 by 4 pi epsilon naught small q capital Q by L, and first I substitute upper limit 1 minus 1 by r plus L minus 1 by r. Yeah. So now what happened? F is equals to 1 by 4 pi epsilon naught and small q capital Q by L, right? Minus of minus plus, right? So 1 by r minus 1 by r plus L. Now the F is equals to 1 by 4 pi epsilon naught small q capital Q by L small r minus r by r into r plus L. This is the equation for the force between the charged particle and a uniformly distributed rod. 1 by 4 pi epsilon naught small q capital Q by L into, here small r cap, I mean plus or minus cancel, and L by r into r plus L, right? And this L get cancelled. Therefore the force between them is 1 by 4 pi epsilon naught small q capital Q by r into r plus L. So this is the formula for the force between a charged particle and uniformly distributed rod, right? And it is an axial line, right? If it is on a equatorial point, then we'll see that in the next problem. Thank you.